Hey, good morning. Welcome to our homework 1.3, chapter 1, lesson 3. We're going to be going over the notes on measuring angles this morning or whenever you happen to be watching this. And so let's go ahead and jump right in. Hope these videos are helpful. And again, I'll try to keep them as detailed, but also as quick as possible. So here we go. We got definitions. We're going to be talking about angles now. We're moving on from lines and planes and segments and those sorts of things to now another key aspect of geometry and shapes, which is the direction or the way in which those lines and segments interact with each other. And so we call those angles. And so here we go. We're going to be looking at acute angle, obtuse angle, right angle, straight angle, and then we only have one question for this particular assignment. So let's get started. So again, an angle is basically a meeting of two different separate lines or segments. And so if I just kind of so if you've got a line here and then another line and they intersect, then you're going to create these things called angles, which is the measurement of the degrees at which these lines are intersecting. Okay, and so depending on how a line or a segment hits, you are now creating these angles. Okay, and so one of the most basic ways to talk about angles is to to categorize them based on their size. And so an acute angle, as we've written here, is an angle that is less than 90 degrees. So a quick, easy way to remember 90 degrees is 90 degrees basically makes a perpendicular and a horizontal line where they meet. And so this is a right angle. And so an acute angle is anything less than that. So this is a right angle, which is actually one of our terms. But so an acute angle is anything of a smaller degree than that. So I've got an example here or an example here. Okay, anything that looks slightly less than perpendicular, even something like more like this, those are all acute angles. And so you can define less than 90 and then provide some examples. Okay, so then we have then obtuse. You can begin to see it as an angle that is greater than 90 degrees. And so still referencing our right angle above, an obtuse angle would look something more like this. Okay, where now I'm very much past straight up and down, vertical and horizontal, or again, even something slightly less so like this. Those would all be obtuse angles. Okay, and then as I already mentioned, kind of the standard or the dividing line between those two is what we call a right angle. A very nice angle because not only does it divide acute from obtuse angles, but we know exactly what it measures. In other words, that's our 90-degree angle. And usually an indicator, just like we had the hash marks that showed congruency or bisected line segments, the little box in the corner, that tells you without using any words that is a 90-degree angle. And so I know that angle right there is in fact equal to 90 degrees. Whereas up here, these angles, all of these angles here, this is more than 90 degrees in each of these cases. And then for the acute, these are all less. This angle here is less than that straight up and down 90 degrees. Okay. Okay. So then a straight angle is an angle that is equal to 180 degrees. So it's actually two right angles together. It basically looks like a line. And that's why it's called a straight angle, is because you might think, oh, look, that's just a line. We talked about lines, or that's just a segment. But you want to remember that a line actually has a certain amount of degrees. And it's the combination of two of those right angles. And so the measurement of this angle here is, as it says there, 180 degrees. It can also be thought of as if we put an endpoint in there, part of the definition of a straight angle is that it's two opposite rays, because basically I have one ray extending this way, and remember opposite rays are two rays that extend in the exact opposite direction. So whenever you have two opposite rays, you're forming a line. And that straight line, every straight line or every line has an angle of 180 degrees. You can also begin to infer, because this 180 degrees would apply to both sides, where this is 180 and this is 180. And so you can see, oh, there's my full circle. If I add those two 180s together and I go all the way around, 180 plus 180, there's my 360 degrees. Okay, so whenever we talk about angles, you're operating within that 360 degree uh, uh, amount. It's kind of our maximum if you're going to go one time in a circle. And so half of that, the straight angle, is 180. And then a quarter of that, if I want to just keep sketching on this, that would then be a half of 180, and that's where we get our 90 degrees. Okay, so those are our four primary types of angles discussing today. 1.4, we'll get into a few others: acute, obtuse, right, and then a straight angle, or basically a straight line, or two opposite rays. Okay, so let's look at a practice question of how we are going to be asked to solve some of these. And I waited to draw it so we could kind of draw it together in the same process. So our one question for 1.3 says BD bisects angle ABC. Okay, so let's draw angle ABC. It doesn't tell me what type of angle it is, so I'm just going to draw kind of a random angle. I don't know for sure actually whether it's obtuse or acute, but I can draw my angle. And so key thing here, how do we name angles? You'll see angles start to get very lettery. We really get into our alphabet soup. And when you start to do the exercises, if you don't pay careful attention to the ordering of the letters, it can be a little confusing. So here we go. So if we say angle ABC, I would have to label this as so, A, B, C. The key being that the middle letter, the B, is right here at the corner, or the hinge, or we call this the vertex. Okay, so the middle letter is always the vertex. I could put the C up top and the A at the bottom. That's not as important. I could call it ABC or ABC or ABC, but we got to make sure that B is in fact the middle letter. Okay, and the way you would write this, just providing you some extra info, is you would write this as angle A, B, C. And as long as B there is that middle vertex, corner, hinge, whatever you want to call it. Okay, and so now going back to the question, BD is a bisector, bisects it. So if you remember what bisect means to cut evenly in half. So whatever type of angle I've drawn here, I need to roughly draw a bisector that's approximately in the middle. So we'll go with that. And since it's called BD, notice that's because it's coming here from B. That means it must have point D out here. So there's my bisector, BD. Alrighty. And now we have some algebra, some measurements. So we're going to read these careful. First of all, it says find angle ABC. So what I'm looking for is ABC. So that means I'm looking for this entire angle. I want to know what is that entire angle. And they're going to give me some stuff to help me. ABD is 5y minus 3. So A, B, I'm going to trace it here, D. Okay, you can see that. You follow the order of the letters that they give you, and that tells you which angle they're talking about. Again, that's really important so that you can correctly identify which angle the problem or the info applies to. So let me show that again. If we're talking about angle ABD, it's A, B, D. So we're talking about this angle here, and that one is in fact 5y minus 3. And the other angle, DBC, again, trace it. And this is why it was important to draw an accurate drawing. But DBC, okay, so we're talking about this bottom angle here. It says that is 3y plus 5. So there we go. We need to find the larger angle, ABC, ABC, and they've told us each of the two different pieces. So notice, as I've said on previous homeworks, we have they're asking us, they've given us expressions, 5y minus 3, 3y plus 5. So that means we need to write an equation. In other words, equation means equal. Something is going to equal something else. And so I have to use what I've learned to figure that out. The key word here is bisector. In other words, we know that these two angles, I don't know what they add up to. It didn't say they were complementary or supplementary or right angles, but I do know they're bisected. So in other words, these angles are congruent to each other. And so that's my equation. 5y minus 3 equals 3y plus 5. And now we just go into algebra mode and solve that. You want to get the y's together and then get the constants together. I have a 5y and a 3y. 3y is smaller, so I'm going to subtract that first. I don't like to have negatives. Whatever you do on one side, do to the other. If you're doing it right, something should always cancel on one side to make it a little simpler. And then that leaves me with 2y on this side minus 3 equals 5. I'm going to go real slow through the algebra for these first couple weeks just to kind of make sure we're all on board with that. And then I'll eventually speed up down the road. Now I need to get the constants together. How do I move that? I have a negative 3 and a positive 5. Well, I'm going to move this to the right. So I'm going to, opposite of subtracting 3 is adding 3. So I'm going to add 3 to both sides. That will appropriately cancel out. So now we've got our 2y equals 8. What's our opposite of multiplying by 2? Opposite of multiplication is division. And again, if I did it right, the 2's divide into 1, so they're canceling out. And so now I have y is equal to 4. So very good. I found y, but again, what did the problem actually want me to find? Oh, I need to use y to find angle ABC. Okay, so we can plan that for a second here, because if I plug it into 3y plus 5, that will give me the bottom angle, or half of the angle. So thinking ahead, I can think, okay, if I plug that in, I'll have angle DBC, and that will be half of it. So then I can just double it, and I'll know what the whole angle is equal to. So let's just plug it in. 3, let me scroll up just a little bit. So 3y, or 3 times 4 plus 5. 12 plus 5, and that is 17. 17. So DBC is equal to 17. That's only half of the angle, because again, that's why that word bisect is so powerful, because you know the two halves are equal to each other. So if I just take this and multiply it by 2, I can see that the entire angle must be 34. And now, since we were talking about angles, I don't want to leave what I call naked number. Always put your units on. Don't be caught with naked numbers. It's very embarrassing. 2 times 17 is 34 degrees. And we don't have to write out the word degrees. We can just put the little superseded circle. Okay, so this is the kind of the typical, it's the same thing as like what we did with our segments in 1.2, but now we're doing it with our knowledge of angles. And again, you're just making sure you can draw and label appropriately what you're looking at. And then you want to set up your equation. Very important. Again, something will always equal something else. And then as long as you set up your equation right, you work through your algebra skills. Usually there'll be a plugging back in step in order to find an actual measurement. And you just proceed as we followed. Most problems will be very, very similar. The key will be the setup. The other key is, as I said, correctly identifying your angles, going slowly and saying, okay, ABD, DBC, ABC. Because if you just say those very quickly, or you look at the page and you just see all these letters, it can be very confusing. And you want to remember that when they give you the letter order, that's describing the specific angle that you're trying to trace out. All right, there'll be a number of practice problems on our exercises. And so check into that video. Exercises will be page 24, 1 through 9, 17 through 21, 31, and 41 through 43 odd. But that'll be written on the homework description as well as on the exercise video. So good luck, and thanks for tuning in.